Okay, so I will send around the rosters. We have the DNR roster with the colored emblem, state and your employer, so the water system you work with. Missouri Rural Water Association has recently changed our roster or sign-up sheet, and this is what we'll use to send you a certificate of completion for today's class. And we've changed it because, for one thing, since we've done away with sending out mailers about classes coming your way and expecting everybody to be more electronic, we are saying here's a catch in between, a little safety net, that you can provide us your mobile phone number, you can provide us your email, and we can communicate with you that way. We're not sending out messages all the time and pestering you, but simply when there's an event like a training class somewhere within 50 miles of your location, we will then put it in our, they send it out in batches so that it goes for regional areas based on zip code. So they can help get the word to you, excuse me, to you, and hopefully then you won't miss it in case you hadn't gotten to checking that website recently. So you'll see each has two rows. You got a little shaded and then a clear and shaded box that represents, okay, so this area is for a separate person on the shaded lines versus the white lines. Your name, your email address, your mobile phone number, your cell number, your mailing address, still the physical mailing address for the physical form that they, as yet, still send, hard copy piece of paper or certificate of completion, and then your mobile carrier, AT&T, Verizon, or whoever that might be. So I'd ask you to put your info on both sets of papers. I can pass around a pen here too to go with it if you need a pen. Okay, so good. Hope you had a good lunch. Get launched back into it. Finished off that last session with cross-connection control. And now I'll talk a little bit about meters. Of course, some of the basics are the meter is really the cash register. It is really the thing that we want to register as much water precisely as possible. It's kind of like the equivalent of going to Walmart when you have a meter that's under registering and having a grocery cart full of groceries and Walmart saying, well, just take half of them out and we'll scan them and the rest of the year's free. Well, you know, they wouldn't do that, and if they did do it, Walmart wouldn't be the giant retailer it is today. They wouldn't even maybe exist anymore, because eventually you can't pay the bills, you can't pay your employees. So we want meters to be as accurate as possible. They register our water production at our master meters, and they provide process control, as in we know our flow accurately, then we can more precisely pinpoint our dosing on our chemical feeds for all the things that we need for treatment processes, as well as disinfecting our water. Leak determination, of course, that comparison between those master meters and all those meters out there used to register the volumes that those individual homes and businesses are using, and be able to compare the two. And therefore then calculate, track our water loss and provide that information, not only for ourselves and that, which can also be a tool to determine efficiencies of pumps and all kinds of stuff, but also in good stuff for DNR. Here's just a scenario of what a small system might encounter. 150 metered customers, $30 average monthly water bill. Doesn't sound too unusual for a low system. They only have $54,000 in annual revenue if all the meters are reading accurately. Small 5% average underread meters, not too terrible, not too bad, 5% loss. But how much would 5% loss represent in terms of dollars? Who wants to whip out that calculator, phone, whatever, and do it? Anybody want to do it? Mike, you were doing it earlier. Anybody want to take the second shift? Or Mike, you want to do it? I'm asking you just as you're swallowing food. I'm like the waiter or waitress in the restaurant. How is everything? Good. So you're taking 54,000 and you're going to multiply it by 0.05. That would be our 5% loss. 54,000 times 0.05. Tell us how much that is. Yes, sir.
2,700?
2,700. Okay, now we went from mono to barely audible audio to stereo. Now we have stereophonic calculations going on. I like it. Okay. So $2,700 is what it would cost the system to buy all new meters, and it sounds pretty stiff as a price when you think this is our revenue here, and we're not getting it all because we're losing money because of that amount. So that's what we could be getting extra on, what we should be getting as part of this at 2,700 wrong. Now, each meter is going to cost us $80. So if we are going to replace 100% of our meters, if you would, 150 times 80, and what is that amount to?
150 times 80?
Yes, sir.
$12,000.
$12,000. So $12,000 is what it's going to cost to replace our meters. So how would we determine when we're going to get the payback, assuming all of our new meters are accurate? Remind them with the assumption that they're accurate. How would we figure out how to determine what our payback time frame would be?
Like the cost would be flossing more.
Okay. So the cost of the meter, $12,000, is what it's going to cost us. And divide that by the lost water, right? $2,700 in a year's time. And when you do that, excellent, that's exactly right. What would you get? So 12,000 divided by the cost of meters, all new meters divided by 2,700. What does that give?
Almost 6 years.
What is it?
Almost 6 years.
Almost 6 years?
4.44 or 4 years.
Okay. You did that in your head. That's pretty impressive. Okay. Yeah, when I do it on the calculator, I get 4.44, something like that. Almost 4.5 years it takes, which means we have about a little more than 5.5 years of full revenue. So when we do it that way, we actually get extra chunk of change there that we were just letting slip past us. Actually, that extra, and I'm not asking necessarily to do it, but that extra 5.5 years of getting $2,700 amounts to, and I've got it down here somewhere in my notes on my screen, $14,850. $14,850 of extra revenue in that 5.5 years, which more than pays for the next round of new meters. Maybe not, because inflation will go up. It might be just about break even with that. But the point being there, once you get that revenue, boy, as an enterprising water operator who can crunch those numbers and figure out what kind of added revenue we could get with new meters, you might be looking at possibly a raise, even if you have to negotiate it, nobody's volunteering it, but maybe water operators should get a little bit of that extra revenue. And certainly should, in my opinion, because that's good. There should be some incentive for all staff to make the business, I don't care if it's Walmart, I don't care if it's the water utility, I don't care if it's IBM or Apple. Some incentive for the staff to make the company more efficient. There should always be some kind of incentive, right? That would be, at least in an ideal setting, that would be a good thing.
I say it goes toward equipment, which
You
is
said-
ultimately doing the same thing, but you're not getting your raise.
Say-
Thanks
say-
for playing.
I'm sorry, say it again, because I missed the very first part.
Saying they're gonna get that money more likely to go toward equipment to make the job better and incentive for everything getting better, but it's not gonna go toward a raise. But that's, I like the way you're thinking for sure.
I understand that. That might still be an incentive in an indirect way, but I agree with you. If your system's like my system I came from, the last thing they want to spend money on is the labor force, because they look at that as the single biggest expense, and it is. So that's the last thing they want to put more money into. They want to put it on. So you can kind of understand that. That's why you use the math and the formulas to help them better see your value, as opposed to buying it on some equipment or something. I came from a city, so for us it was a new patrol car for the police department. They always like those shiny things that people can see as they drove around, But anything but spend it on that worker. You were right. So positive displacement meters are accurate for low flow instances. They are built for low flow. So typically they have a chamber where water goes into a hole, only so much water, and it will send that information calibrated to the register. If more water goes through than they can take, than they were built to read, it'll go right past the chamber and go unread. So that's why they'll underread at high flow. Sounds like, no, that doesn't sound intuitive. It sounds like they would spit even faster or whatever, but it's not about that. It's about that chamber. Mutating disc is one of those more common designs. That's that kind of warble-like disc in there. And here's forgot I have some quick takes on some of these images of these meters.
Badger's disc meters are ideal where there's a low flow rate, making them a perfect choice for residential use. Here's a step-by-step description of that process. Water flows directly into the meter housing. The water first flows through the meter's internal strainer before it enters the measuring chamber. The strainer protects the measuring chamber from damage due to debris in the water. Inside the chamber assembly is a movable disc that's located on a sliding ball guided by a thrust roller. As the water flows into the measuring chamber, it causes the disc to nutate, a motion similar to a coin dropped on a table. Notice that the disc does not rotate, but rather wobbles on its axis. Therefore, the space formed between the disc and the chamber wall has a constant volume as it moves around the chamber. The water in the chamber is a fixed volume or displacement. That's why a disc meter is called a positive displacement meter. The smooth motion of the disc also eliminates the annoying noise produced by some other types of positive displacement meters. As this happens, the nutating disc translates its movement through a magnetic coupling to the register. The water then leaves through the outlet port of the chamber assembly.
So some good, I've got a few of those in here, the quick takes from Badger Meter, not at all taking a side of Badger Meter or trying to endorse that company, but how smart for a company to come up with little educational demonstrations about the internal workings of their meters. I have to say, from my exposure to systems, to a lot of companies, walking around our exhibit hall asking about, do you have a trainer? No. Do you have somebody who's an expert who can speak in front of people? No. Do you have any kind of educational videos? No. Do you have any cutaway equipment? No. Get a lot of no's in companies. There's a definite under-met need in companies to have somebody on staff who can stand up in front of people and talk about, with expertise, about their proprietary equipment and how it functions and that, or to create video. So, if any of you want to change your career or ever thinking about close to retirement, might want to look at a different career. There is an unmet need, or undermet, I'll say, in the world, in industry in general. Velocity meters have a rotor that turns, that registers a known amount of water, sends that to the register, I should say. It's meant for commercial services or industrial use, and the rotor's turn basically gives an accurate measure for large flows. They are intended for large flows only, So this rotor won't even pick up in the stream and turn unless you have 25, 30 gallons per minute flow, possibly. It kind of depends on what it's built for, designed to register. So if you have a low flow, that water's going to go through and not even turn that rotor. So they will under-register water flows that are low flows because they're intended to read high flows. They are typically sized for twice their anticipated flow. If you think the maximum flow at a given location is 25 gallons a minute, then you should probably install one size to be 50 gallons a minute that could read 50 gallons a minute. So for commercial purposes, velocity meters, the large flow meters, are actually sized twice what you anticipate the largest flow would be. Different from the positive displacement meters on the residential side where you have a meter one size smaller than the service line going into the facility. So that's different from that. Let's see, for twice the anticipated flows, what's used? Oh, for high and low flows, the combination. What would be high and low?
Mineral read,
What's that?
mineral read meter thing, you don't have them, and then, mineral read.
Mineral read, I'm not familiar with the mineral read. Have you encountered that, Jim? Mineral read? I'm not gonna say no because I don't know, but
I just put 3 new ones in, I don't know if that's exactly what they're called, but I know they have no moving parts in this guy.
Like a sonic meter?
Yeah, something, yeah, there you go.
sonic meter.
I thought that's how they read was the minerals that went through it. So we changed them for the core at the lake, is the ones that they had set in it, been there for about 17, 18 years. And they were 2-inch meters. But now that we put these new ones in, I got a feeling I'm gonna need some better information to give them because
Their water usage is going
that their usage is definitely a lot different, you know, than what it was on the old meters that wasn't reading right.
Which is usually the case when a residential customer is saying, oh, you're charging me too much, and you put a new meter in. It's because the old meter's under registering and find out that
And that goes the other way.
it goes the other way. So for them, I can't speak to it, but a sonic meter will read the sound, and I don't know if it would read equally accurately at a low flow
Yes.
versus a high flow. Does it, Jim?
Yes, Master Meter makes one, and I forget the name of it. But they demoed at one of our conferences, and they had water just dripping through it slowly, and it actually read the low flow. And the high flow is the same way, it reads it.
It did,
And I
okay.
forget the name of them. It was a 2-inch meter, and they work real well in schools and places that don't register a lot of water flow.
Okay.
So there's a couple of them that just run a couple bathrooms. For a 2-inch, even for the 2-inch main to go in there, it's kind of excessive. But that was kind of one of the issues, they wasn't sure with the old meters that was in there, if they was even picking up the right. Now, the campgrounds and stuff, we got a lot going through there in the campgrounds, where we just go into a couple of outhouses, it's not getting much flow at all through them, but.
So that's,
Now that I've changed them, we just read the meters this month, not a favorite thing to do, but there definitely is a usage difference. I'm sure they're gonna be hitting me up for some information more about exactly how they do work and all that stuff.
yeah, if you've got literature, since you just bought a few of them new, you said? So the literature that comes with it, or get with the supplier to get you literature about their accuracy, because they might need a little explanation to help buffer the shock of
Yeah.
how their water bill went up. On the flip side of that is, you've got the discount for a long
And
time,
that's my point.
under registering, yes, sir.
Octave is the name of the master meter that's called, but also that meter, if they're new meters, they should have a tag along with them that shows their accuracy at all 3 flows. That should have been part of the documentation with it, that you might could use to show those people that it's already verified that those percentages should be 2% plus or minus of 100%.
That's a good point, yeah, so they show the accuracies on there, so they've been tested for that. Although.
And those work good, but I find that pictures and stuff works
Yeah.
so that, people can actually see a picture, reading numbers and stuff like that, they can't wrap their head around as good as they can see drips or something coming through or something, then they can kind of figure it out a little better.
Yeah, some meters are, in today's technology, are really built to, like you said, real low flow and you register just a drip. And that's what you want because, really of any of your meters, I think even a residential, I'm pleased to hear that commercial 2-inch meter can read those low flows like that. You do need it to read even when just a toilet tank is seeping a little bit and refilling, because that'll take a lot of water in a month's time, use a lot of water. But that low flow won't turn a big old mechanical 2-inch meter if it wouldn't touch it. So that's good to hear that they have a high sensitivity. Same thing when you're testing meters in residence. If you're testing your meters for accuracy, you want to really choke down that so you don't have hardly any filter on, a real small screen, because you want to see, are they turning at all? Are they measuring compared to the meter you're contrasting with in terms of accuracy? One story I have with that, for a short period of time, I was actually taking a meter out into the field and helping systems, some of the small systems, when I was kind of working with the DNR, still on reservoir water, but still working kind of with the DNR to help some of the systems that were having indicated on their, you might have seen this year, the TMF survey. And one of the questions in the past survey would say, do you have a meter change out? And if the system indicated it did not have a meter change out, they became a priority on the DNR, for the DNR, with the contract they had with Reservoir Water. So while I was doing that at the time, I was out testing meters, and I came across 51-year-old water system, the older gentleman who's the chairman of the board of the water system down here in your neck of the woods, way down there in New Madrid County, and said some of these meters are the original meters. Oh my goodness, the original meters. I can tell you, you're going to have some problems in terms of what kind of water accuracy you're getting in terms of accounting for the water use. But lo and behold, he did have some, because we pulled multiple meters and tested them, and he did have some that were 92% efficient, which to me was even kind of phenomenally accurate for being old, but still, that was too much to lose. I pulled an old Rockwell meter that was, he said, I know this one's an original, 51 years in service. And it was a home that right then was nobody was residing in, so it's now been sitting for a while too, and I don't know how long it was sitting. We tested it. That thing was 100% accurate. At that moment, I remember the phrase, they don't make them like they used to. And I'm thinking, yeah, I guess back 51 years ago, they made meters to last and be accurate forever. They were built to literally last forever. Nowadays, that's not true. DNR typically says 10 years for a service meter on a home. 10 years is about the life expectancy.
Take one of them apart.
What's that?
Take the old one apart, there ain't that many parts.
On the,
On
is
the
that right?
meters, you take a new meter apart, you can't lay all the parts out, there's so much junk in there.
So the more moving things, the more fail, the more chances for fail maybe, or for flaws in terms of its registry. Good point. I've seen an old meter sitting that was working, and after just a short while of sitting, it didn't even turn anymore. And it's simply because of the mineral from the water going through it, sitting without being taken apart, disassembled and cleaned before we put it on a shelf. And now it's sat on the shelf without being cleaned, and that mineral froze it up completely. So if you are ever pulling a meter and going to put it back in service, maybe a customer doesn't live there right now, it's a rental or whatever, vacant home, and you're going to install it back at the same location like we tend to do sometimes, you want to, when you pull it, you want to really give it a good clean, take it apart, assemble it, clean it so that you don't have all that mineral just freezing it up over time, sitting on the shelf. So, important things to just kind of be What I was thinking of before the sonic discussion came up, and I'm glad you educated me on that, is the compound meter. Compound meters that are typically have the low flow positive displacement unit inside the same housing as a large velocity meter for various uses, where you've got mostly low flows, but every once in a while you get a surge in flow. You know, like in school where kids are in class or they're out for the summer, nothing going on at all, hardly flow-wise, other than a janitor during summer or doing floors or something. Then, when school's in place and all of a sudden it's lunchtime or recess or whatever, everybody's using the bathrooms, the toilets are refilling and that kind of stuff. Dishes are being washed, and then you get high flow. So those are good for those instances. And Badger's got a good little quick video on that too, to kind of just show the functionality of it.
Water flows directly into the single compound meter housing. If the water is flowing through the meter in a high flow condition, the pressure differential causes the spring-loaded valve assembly to open. It flows past the straightening vanes at the entrance to the measuring element, helping to condition the water flow. As the water flows into the element, it comes in contact with the rotor, which lifts into its floating position and begins to spin. A right-angle worm gear couples the rotor to a vertical spindle, which in turn drives a gear set that rotates a coupled magnet on the wet side of the meter. The rotor's revolutions are therefore transmitted via this coupling through the cover plate to the register. Finally, the water flows into the downstream side of the meter's housing, where the valve assembly resides. The water then exits through the outlet. It's important to note that in a high flow condition, a portion of the water still flows through the disc chamber before exiting the meter. To see how a disc meter operates, select Disc Meter.
So to be aware that where cancel that. Hit that again. So some water is still being registered and measured by the low flow. But you can get chemical deposition from treatment processes or just natural mineral in water. Iron manganese is a very easy, natural, regular, common thing to find in water. But also if you're doing any kind of chemical use for treatment, iron removal, or lime softening, or surface water, you're using chemicals that can build up over time on moving parts that eventually slow down and wear out altogether these parts, and that's off of a rotor there or a meter. Venturi meters have what I call a design that's kind of like a sideways hourglass, where the throat narrows in the middle, and it's one of these things that contrasts the pressure at that narrow throat piece, which would be less because we're choking down the flow, to the upstream pressure. And so it's what we call a pressure differential. And they're good for a large range of flows. Of course, we have rotometers. Little balls are cones that float in water to measure. Typically, these are for measuring the gas flow from our chlorine storage tanks. Sonic meter you had mentioned, and that's a sound measurement. Now, sound can be distorted. That's why I wasn't sure how accurate they were, depending on the flow volume. Sound can be distorted by upstream obstruction. So you do want to make sure there's a distance of, I think they typically say 10 times the pipe diameter upstream should be free of obstruction, free of bends or closed or partially closed valves or whatever. So a 12-inch pipe would have 10, so it's 1 foot, so 10 feet upstream with no bends or anything prior to that meter. Otherwise, you're kind of changing the sound waves that depending on rating. Transducer is measuring typically pressure measurements. It's a differential kind of a thing with atmospheric pressure and the depth of water, oftentimes in a storage tank or in a clear well, that is used for measuring water levels. Magnetic meters, mag meters, are really another interesting design, another interesting invention, you might say, for measuring water, and I thought that was worth taking a quick look at as well.
Badger's mag meters are an ideal solution where challenging metering is required. Here's a step-by-step description of how our mag meters work. The meter tube is lined with a non-conductive hard rubber or PTFE material. Outside the tube, two DC-powered electromagnetic coils sit diametrically opposite of each other. Two electrodes inserted into the tube are set perpendicular to the electromagnetic coils. A third electrode is inserted at the top of the line and senses if the pipe is full. Notice how a magnetic field is created across the entire pipe diameter when the coils are energized. When a conductive fluid, like water, flows through the magnetic field, a voltage is induced across the electrodes. The two electrodes notice the voltage created by the fluid. As a result, the voltage magnitude is directly proportional to the average flow velocity of the fluid. The induced voltage is then amplified and digitally processed to produce an accurate digital or analog signal. This signal can then be used to indicate flow rate for totalization of fluid volume or to communicate or interface with another piece of equipment.
I don't know if accuracy would be thrown off if you have high total dissolved solids in water. We tend to not have that in potable water, so it's not really our concern, but if you were using that for something that was not potable water, and had a lot of solids in it, I don't know it, because the electrical flow actually goes from particle to particle to particle, and I wonder if that nice straight electric charge would be distorted all over the place if you had a lot of that. I don't know the answer to that, but I just started wondering about that as I watched that image. Other meters, we have orifice plate, pitot tube, and single jet. Some of these are also pressure differential type readings, pretty accurate. Multi-jet, and we're going to see a video of a multi-jet, and proportional meter is one that is only reading part of the flow as it's used, and I believe they tend to use that in fire flow. Anybody in here a firefighter? I think they tend to use proportional meters for that. So now we're going to have just a bunch of quick takes. These are not narrated, so these will be the first videos that have no sound deliberately. I mean, there's no failure in our audio equipment now. We've got or maybe they do have sound, but no voice talking. So I think that never ends. I just remember, no, I think it's there all day. I was waiting for that to show a different angle, but I think I'm thinking of the next one. Let's see, the next one. Multi-jet. Getting background noise here, but we're just going to see some water go through this animation here. So, that's kind of neat, but a lot going on in that video. A lot. I guess they're still showing a little more here. Okay, so that's that one. Next one. Helical positive displacement flow.
Positive displacement flow meters divide flows treated into fixed, known volumes and count them to determine the total flow and the flow rate. In a helical rotor meter, the measurement chamber is created by a pair of rotors which turn and create a progressive cavity. As the liquid pushes against the upstream side of the rotors, they turn to move out of the way. As the rotors complete a full rotation, their leading edges close and isolate a volume of fluid from both the inlet and the outlet side of the flow meter. As liquid continues to enter the meter, the trapped portion of fluid is carried along by the rotors until their trailing edges open and the fluid is released to the downstream side of the meter. This process repeats itself continuously. MAX uses a high-resolution encoder to convert the meter's rotation into an electronic signal that's proportional to the volumetric flow through the meter. Since the displacement of the meter is fixed by its physical dimensions, the same amount of liquid is transferred from the inlet to the outlet with each meter rotation. This creates a meter with measurement repeatability better than 0.1% of reading.
That's pretty doggone accurate and pretty sophisticated technology. And this one now, I'm not endorsing any of these companies, but this particular video is endorsing its product, but I thought I'd use it anyway. This Coriolis meter, I've never seen it in actual application used anywhere, but it's pretty interesting.
Unique design, peak performance. The Siemens Cetons FC430, a pioneering Coriolis flow meter. With the Coriolis effect, a physical force is explained. It acts on the medium that is accelerated in a rotating system, like a ball on a rotating disc. Its movement is straight. However, if the observer turns with the disc, the ball is apparently deflected. The same effect occurs with a water hose that rotates around its own axis, like a scarecrow. As soon as water flows through, the hose also twists. The effect also appears with an oscillating movement. The twisting is stronger or weaker, depending on the amount of water flowing through the hose. This effect allows the mass of liquids or gases to be determined. The Siemens Cetons FC430 flow meter functions according to the same principle. Two symmetric metal tubes are set vibrating. This is ensured by a driver coil in the central section. The tubes oscillate with a resonance frequency, similarly to a tuning fork. The oscillation is measured precisely by two pickups at the inlet and outlet sections. If liquids or gases now flow through the tubes, a phase shift occurs, as with a water hose. The pickups measure the spatial and temporal displacement. This determines the amount of liquid or gas flowing through the tubes. The greater the amount, the stronger the tubes oscillate outwards. Siemens presents yet another Coriolis device for measuring mass flow. Thanks to the precision of every detail and its compact form, the Cetons FC430 represents a small revolution, a multi-parameter flow meter with maximum reliability. In addition to the mass, it determines the density of a medium. Denser media have lower frequencies. Put otherwise, water oscillates at a lower frequency than air. For the measurements, multiple parameters such as volume or concentration of substances in a liquid can be derived. Data and results are stored internally and on the innovative sensor flash. They are available at all times as backups, just like the audit trail function and all certificates. Unique design, peak performance. The Siemens Z-Tons FC430, designed for excellence.
I saw that, oh my goodness. There are definitely some geniuses out there who could make, who would guess that this water oscillating and squiggling a line around, once again, if it goes from point A to point B, and I put a rotor that turns when the water goes past and it measures it good enough, wow, that's pretty fascinating. All right, let's see here. Let me get this back to you. So just some of our installation standards for meters. We want them to be watertight, upstream shut off on the meter, have a horizontal plane that they rest in, accessible for getting to them or pulling up when the customer doesn't pay or reading them maybe directly or through remote read, protected and protected from freezing as well. It's typically that empty space from the bottom of the meter pit to the bottom of the meter that actually is the protective barrier against freezing and not to any kind of hazard. Just some of the components that we have, an angle valve that we would see in a meter pit. We have a check valve there on our inline setter, an old model, meter couplers, pits and bonnets. I think I already covered the size, one size smaller than the service line, and that was reminded me about my story. I thought that was pretty interesting. Again, I went in with the assumption of one thing and totally was astounded that it was something else altogether. So meter testing. Do you actively test meters at your systems? If not, it might be something good to do because, you know, even like I said, even a new meter, or a meter that's only been in for 3 or 4 years, could be not giving the accurate information. So we can't assume just because it's new or we installed it a couple years ago it's working, and oh, it's 10 years old, maybe it's not working, because it really doesn't work that way. Different brands have different accuracies. You might have luck with one brand and not have luck with a different brand in terms of reading accurately. So it's a good idea to do it. How about if not doing it by a regular schedule when a customer complains? Is that a time that you might be prompted to go and say, okay, you're saying you don't believe your water bill is, you think it's too high, and of course we know the truth is usually the other way around, but we'll go ahead and flush some water through your line and hook up a calibrated meter. You know, a real easy way to do that is to don't even pull their meter, just get the numbers off their meter and zero out your, if you got a calibrated meter, and hook it up to their, say, garden hose spigot outside and turn on their faucet and let it run for 20 gallons or 100 gallons if you want, whatever. You could do that. Of course, if you're going to really test it, you want to test it against different volumes, right? Like pitching it down to about a quarter of a gallon a minute, maybe even a couple gallons a minute, and maybe a higher flow of 6 gallons a minute, and doing different amounts just to see accuracies in each amount. Because they say 70% of what people use in their home is a medium flow, more like 4 to 6 gallons a minute. And only 15% is the low flow, a couple gallons or less a minute. And maybe that's what their intention is, little, but again, if you have a drippy faucet or a leaking toilet or something. Yes, Mike?
We ran into this with our wholesale customers, St. Peter's and St. Charles.
Yeah.
They have a 42-inch line going under the river, and we got 3 16-inch barrier and sensor meters on that line. And they called us saying that we wanted a meeting because they're charging us too much for water. So we ended up changing the meters out, and come to find out, they had 9 breaks on that 42-inch line.
Oh, wow.
And that's where the water was going.
All right. So they discovered that process of changing it out, or when you put in the new meters, the water volume was still high and it didn't satisfy them,
And then they came back and they put an outside company put a smart ball in the 42-inch line at the meter pit.
Okay.
And then they shot that over. I think the line is like 4 miles long. And it pinpointed where it thought the leaks were, joint leaks and other things that was going on. So it really was our meter.
Yeah.
But what their meter was saying and then what our meter was saying, one of the 2 different numbers. So one of I said, well, what you could do is do a 24-hour test. We read our meter at the same time you read yours, and then 24 hours later we do the same thing and see if we come up with the same number. So we did that, but they never came back with fair results. And then the next thing I hear, they used the smart ball to put it in line.
Is that right?
You know, so they usually had a discrepancy, but it wasn't on our side.
Was that happening now? So after you put the new meters in?
Right.
And then they were believing that those must be accurate, so now something must be wrong. Because their numbers still weren't stacking up to your comparison. That's interesting. My goodness, small line, 4-inch line with a small leak, lose a lot of water, but a 42-inch line with a small leak. Whew. My goodness, that's a big monster line.
I'm more curious about this smart ball thing you're talking about.
Yeah, what is that now? Is that something where they can actually track the progress of the ball?
Yeah, it's a ball about as big as a softball, and they can inject it into the line, and I guess it has like a negative buoyancy to it, so it'll just float along the pipe, and they'll run flow through the pipe to carry the ball, and the ball is sending out some sort of sonar type signal, and that's what whoever is reading it knows how to interpret it.
So I guess that's something like the big line systems.
Yeah.
Our 8 inches as big as we got, and that'd be really handy for pinpointing stuff that.
I've heard of it though for smaller lines. Jim, have you heard of it? I've heard of it for smaller lines.
Smaller lines, we just usually use the correlator.
Correlator,
Yeah.
Yeah. But I hadn't heard of that before. I think smaller lines to detect leaks, but I forget who it was. It's probably.
What is the distance apart on the correlator? How far can you go in one span when you're checking the area?
PVC, you can only go about 300 feet.
About
That-
300?
That's the whole dilemma of it. What works good on systems like yours is if you got a branch line that's like a dead end line that's not looped, or you can shut it off, is to put on a blank, you tap in with a
Down
cork
longer.
stop.
Down longer.
No, it's just use a test meter. Just tap in with a cork stop on each side of your valve, and then just use a regular 5/8 3/4 meter in it. Shut your valve off, and if there's water flowing through that meter, then you know you've got a leak. I can draw you a picture of it.
That makes sense. I just like the pinpointing thing, you know,
Well-
kind of, when you got that whole road, you know, and instead of digging everything up, you know. I figured it wouldn't be long until somebody had one out, and apparently they already do. The correlation deal, Brad comes up, rate ring, and
Yeah,
uses
the
it.
dilemma with this, it won't do very long distance.
That's
as you
what
see.
we ain't never done nothing real too far.
Yes, sir. What's
Smart ball.
what you got on it? What image?
It's a company called Pure Technology.
Your technology. Smart ball. Oh, okay. Smart ball. And it's meant to detect leaks in lines. Yeah. And I guess it can go on considerably smaller lines than a 42 inch.
Yeah, I was thinking.
Yeah, it seems like I was talking to a supplier, or one of our vendors, and talking about it, but it's been a few years now, and I've forgotten all about it, to be honest, so I don't know that I've seen it applied anyway. But I think it can be applied in small systems. It's pretty cool. Oh yeah, ducks. After a long day of having to do all this work, I need to get a little break, but found something that was somewhat humorous and innocent.
This is our tribute to Skidbit, trained by David Hartley. We're going to do a little twist on his ball routine. Now, Splash, are you ready? Splashers, you can only get that ball when I say 3, do you understand? What if I say 2? It's just 3, right? Okay, then stand. Can you paw it? Touch it. Touch the ball. Back up a little. Gosh, back up a little. Back up. Back up more. Wait. Side step. Wait. Go the other way. Wait. Turn around. Wait. Sit. Sit pretty. Cover. Cover. Good job. Down. Shuffle back. Shuffle back. Down. Walk. Reverse. Go. Reverse. Keep going. Reverse. Go back. Keep going. Back up on it. Wait for it. Here it comes. 1, 2, 2.5, 2 3/4, 28, 3. Shake it. Shake the ball. Shake it. Yes. Hit the ball. Sit ready. Hold the paws. Hold the paws on it. Paws on it. Dig it, go get it. Toss it. Good job, go get it. Toss it. Get it. Toss it. Good girl, get it. It's coming to get you. I'm gonna get your feet. I'm gonna get your feet. Good job.
Smart dog. Yeah, smart dog. Maybe it designed that Coriolis neither. Pretty smart. Sectionalizing valves. Minimum gate valve placement. Ideally, we should have at T's a minimum, I've got a question mark up there, but I think I'll just run through this. A minimum of a couple of valves. I think it's more ideal to have 3 valves, at T's. So we can isolate every section of that line, but maybe in a more realistic sense, 2, in pipe intersections, 3. Valves no farther apart than 500 feet in commercial areas and 800 in residential. What is the purpose of sectionalizing valves anyway? What real value do they add to us? Isolation. Okay. So isolating customers, the more valves, the fewer customers you have out of service when you've got a main break or you have some kind of maintenance you're doing, conducting. So yeah, it really does help to minimize the customer complaint maybe for us. DNR says, we all know for exam purposes, valves should be exercised on an annual basis, right? So valve exercise every year, that keeps them from freezing up, which means they actually continue to work for us as we need them to. The exact location of valves, when we're doing our valve record, we want to know kind of a exact location where the valve is, typically a triangulated location using some permanent reference point, the type of valve, the make, the direction of turns it takes to turn it, close or open, and the size of the valve, the date of installation, and the number of turns, date operated, and the condition of the valve, and any repairs if they're needed, which would probably put a repair order on a valve. And not not just recording it because DNR says we gotta do it, but then when we go to do our valve exercise the next time, we take that record out and we look at it for each location and see how many turns it took to close the valve. You know, it took me 20 turns last year, but I got it done in 17. Well, I didn't become more efficient. I just don't have the valve all the way shut. So if something's obstructing the turning of the valve, I need to open it again and then try to close it again, maybe dislodge downstream if there's any debris in there that's keeping the valve from shutting all the way. What's the old ballpark measure for how big a water line size is? First of all, MRWA endorses having mapping done, and we offer mapping services, so you would always like to know what you got underground. But if you're not sure your maps are accurate or up to date, and you're turning a valve, you can get a pretty good estimate of what size line you've got. Does anybody know what that formula is?
Limitations, takes a closing.
Okay. It is a number of turns. It's 3 times the outer diameter of the pipe plus 2. So if you have a valve that takes 20 turns to fully close it or fully open it, then that would be a 6-inch. A 6 times 3 is 18 plus 2. The AWWA says 4-inch or larger pipe that's accurate for, but I've had operators swear that it works no matter how small on a 2-inch line, that it will give them accurate information too. So I don't know if any of you's tried it. Maybe try using that, testing it, seeing if it works on small lines. So valve designs, linear stroke valves, the gate valves like we use in distribution systems are one of the more common ones where the valve rises in a straight line on a threaded stem. Our rotary valve that turns a quarter of a turn at 90 degrees to fully open, fully close. Diaphragm valve has leather or rubber piece that actually helps control the flow volume through the valve. Can be partially opened or partially closed. Again, I have some quick takes on some of these images just to kind of give you some of the images of these in operation. Or I think I do. That pop-up window doesn't look promising. Oh, you embedded object to keep you safe. Don't keep me safe, let me use it. Okay, we might not get to that one. Computer's trying to keep me safer than I want to be. So, globe valve. So globe has almost like a wine bottle cork, almost like a tapered disc that lowers and raises. So similar to the globe valve design, and it too can regulate the flow of water going through. Some valves you really aren't for regulating flow, therefore just totally stopping flow or totally open flow. And I'm going to try again, and if it doesn't work, I won't keep trying these. This must just be from a source that the computer is questioning. So I need to eliminate those few slides from this presentation for the new computer's sake. So gate valve, already talked about. There's a couple of images here of gate valve. A better image, a little closer up image of partly open gate valve. Rotary valve, a sphere with a hole or a barrel opening through it, like a ball or butterfly valve, cone or plug. 90-degree turn. Ball valves are meant to be open fully or closed fully. A butterfly valve can be operated at any number of, so this valve with that 90 degrees, it's fully open when it's aimed like that with the flow of water going past it, but it can be closed partially to throttle the flow of water going through it. You might do that as a temporary measure until your pump specialist can come in. If you determine, like this butterfly valve is on the discharge side of a high service pump, and if I had cavitation happening at my high service pump, That means part of that flow is being restricted and it's pulling in at a higher velocity because it's short-circuiting. It's not going through all the openings. It's got a less of an opening to go through. That means bringing in more air, thus the little air pockets that can explode on themselves or implode and cause damage to the impeller and the pump. So if I have that problem, well, that's because it's too high of a velocity coming in. I can actually partially close my butterfly valve at the discharge side and lower that a little bit, maybe lower that velocity temporarily so I can get somebody in. Ball valve there just partially closed just to show the ball valve better, another one, but not meant to be operated that way. Linear stroke valves are globe and gate valves, and rotary common ones are ball and butterfly valves. Air and vacuum relief valves, air collects at high spots and it causes the column to separate or float because there's no water up there, it's air, it falls away from the seal and that allows the air to escape. And if we have water, a portable water tank attached to that can deliver water when that drops away and the air is released, it can fill that void and again prevent that oscillating waves that I was talking about earlier. Blow off and drain valves are good for low points, blow off for sediment, where sediment's going to collect, or high points where air is going to accumulate. This is storage tank. This is nice. This is something different. This is meant to be another little break from the action. No, I didn't even move that around. I think this will work. Some big heavy equipment images.
Hello, this release is dedicated to all lovers of heavy equipment and monster machines. And today we have the largest excavators, cranes, tractors, and incredibly heavy machinery. Here we go. Crawler is a real monster truck. This is one of the most powerful and incredibly noisy of land vehicles. Crawler carefully transports space shuttles and Apollo missions. This machine weighs 2,500 tons and carries a cargo weighing up to 6,000 tons. So, the total weight of the conveyor, along with the cargo, more than 8,000 tons. Its dimensions are also impressive. 131 feet long and 115 feet wide. Really big monster that powered by two diesel engines with a capacity of 2,750 horsepower each. Big Muskie is the largest moving mechanism on Earth. Its weight is 13,000 tons, length is 490 feet, and its height is more than 220 feet. To start the car, it needs a crew of 5 people. An excavator bucket can easily fit 12 cars. On its construction, $25 million were spent, and during its exploitation, Big Muskie produced more than 20 million tons of coal. Bagger 288 is the largest bucket wheel excavator in the world. The German company Krupp created this miracle for carrying out work in the coal mines. By its size, it surpassed the NASA's crane tracker, 328 feet in height and 705 feet in length, and weighed 13.5 thousand tons. The creation of this giant was spent with $100 million and 5 years of work. Bagger 288 digging at a record high speed, 33 feet of trench per minute. Mammoet is a self-propelled modular conveyor. Its ability is to transport any construction of the most incredible dimensions. For example, a bridge, an oil platform, or ships. It is called modular because several such high-duty conveyors can be combined and work together as a single whole. Interestingly, these machines are controlled with just an electronic control panel. Bridge Layer SLJ 900 is intended for building bridges which consist of many spans. This 328 feet monster can independently move, transport, and fasten the finished segments of the bridge canvas to pre-installed supports. Thanks to this machine, the speed and efficiency of building bridges has increased significantly, and the need for human labor has come down to a minimum. The largest mobile crane in the world is also the most powerful telescopic crane with the longest telescopic boom, 8 parts of which are automatically retracted and installed on the desired length. All mobile cranes have one significant drawback. It's a small load capacity. German engineers have corrected the situation when they created this monster truck, because it could lift 1,200 tons of cargo to a height of 590 feet. The absolutely unique Japanese crane SK3500D went into the Guinness Book of World Records as the biggest crane destroyer of buildings and skyscrapers in the world. At the end of the machine, you can see huge nippers that allow this crane to operate at a height of 213 feet. This is an absolute world record for the destruction of objects. And here's a representative of the Belarusian automobile plant. Belaz 75710. This is the world's largest dump truck with a payload capacity of 490 tons. The first eye-catching thing is its extraordinary size. The length is 66 feet, the width is about 33 feet, and the height is 26 feet. This monster truck went into the Guinness Book because it carried 503 tons of cargo in a testing range. The price of such a vehicle is about $10 million. That's why it is produced by units and only by order. Its operation on ordinary roads is almost impossible because engineering communications can't withstand this machine, and for a turn, it needs at least 148 feet of free space. Big Bud 747 is the largest tractor in the world, which has remained so for more than 30 years. It was designed for 2 brother agronomists and remains the only one of its kind. And even today, no agricultural company has developed a technique similar to this tractor. Dimensions of the monster truck are startling. The length is 27 feet, the width is 20 feet, and the height is 15 feet. The machine can treat 400 hectares of soil in a day. Monster truck has doggish appetite. In a minute, there is an expenditure of 6.5 liters of diesel fuel. The world's largest tunnel-tunneling machine is called Bertha. The cost of this incredible machine is more than $80 million, and its height is like a 5-story house. To transport Bertha from Japan to its destination, it was dismantled into 41 parts, the heaviest weight of which was 900 tons. It must build a traffic intersection under Seattle. In 2013, starting work, it broke down almost immediately, and for many months it had to be repaired, recycled, and even modified. But to date, Bertha has already managed to pass 76% of its way by cutting a passage through 2 kilometers of rock, mud, sand, and earth and clay. After 4 years of travel, Bertha will come out of Earth in June this year. And here we see 116 conventional excavators and the most productive 43 hours of work. In order to not create traffic jams, in Beijing, they decided to demolish the old bridge and put in its place a new one as quickly as possible. So, starting on Friday night, all excavators destroyed the bridge in just 4 hours. And after another 43 hours, the traffic was restored to the new bridge. The Chinese are monsters. There's no other word. And finally, a unique copy of the Dodge Power Wagon, made to order for an Arab shape, also known as the rainbow shape. This copy is not reduced, but enlarged 8 times. The weight of this super pickup is 50 tons, and inside there are luxurious 4-room apartments with kitchen and bathroom. This incredible machine is equipped with an engine and is even able to move, though not too fast. Thank you all for watching. I hope you enjoyed the video.
Oh, it's not that, just a nice little break from the action and some big equipment. one is 12 houses, or, you know, you could give more comparisons. I see that brings us right up to 2 o'clock. I'll take a 15-minute break. How many folks in here are the designated person in charge of your water system, the chief operator, public works director, whatever you want to call it? Okay, there's 1, 2. Anybody? Guy in charge? You are, aren't you? 42-year person back there.
I resigned, I'm not in charge.
You're, say that again?
You say in charge?
Yeah,
I resigned,
you're not.
I did 3 years ago.
Oh, okay. Okay, so really, we just talked to 2 folks. I just need to kind of keep track of who's who when it comes to how many folks are managers versus the rest of us non-managerial types, you know. Okay, all right, where's my, here it is. So now we're gonna kind of move into water storage tanks. So actually, I just backed up there a slide or 2. Water storage tanks, some images there of smiley faces, and I have some creative design images from around the country here. Top left is what they call that witch hat design. I think riveted steel, which is not really a very good type of roof top for a water storage tank. I don't think it has a perfect seal on it between the roof and the walls of the tank. And then the top right is a single pedestal or single leg, single bed, and then you got multi-pedestal or multi-bed elevated storage tanks there at the bottom. And then all their kinds of creative designs. We've got a peach, we've got a watermelon, we've got an ear of corn, we've got some interesting things. I think that's a flowery design there, a teacup. Not sure what that's supposed to look like, but it's creative coloring. Someone's sentiments for their town, I guess. Interesting design. This flying saucer almost looking kind of thing up there. And they just have a lot of dairy cows or something on this painted on the side here. Almost blends right into the landscape on that design. Some more, a little cabin there. You got a pineapple up here. Another watermelon. Whoa. Chicken. Another kind of a interesting looking design. Cone-like shape. Soccer ball. So just interesting things. I didn't have a view of Unity Village has its bell tower for the church is actually a water storage, and I think there's one of those similar kind of things in St. Louis, but I don't know that. But they're over there at least some in Kansas City, and I was actually there at one point in filming from the top, looking down onto the flowery beds below. Didn't even think, get off here and go away and take a picture of the bell tower. So I don't have it, and I didn't find it when I was doing searches. I think that's a repeat. I think I had that one in here before. So just different kinds of towers with antennas on them. In that, who can name that design of a water elevated storage tank? What do they call that with these corrugated image? Anybody?
Pillar.
Yeah, it is. It is like a pillar, isn't it? They call that a fluted column. You see that in various places. My neck of the woods, just a town north of where I live, or the next town north is Farmington. They have one that looks like that. I know St. Charles County has a big 2 million gallon tank like that. But where that's a standpipe, but that's a standpipe. What's this? A reclining pipe, maybe?
Lay down.
A lay down pipe, yeah. An interesting way to put, I've not seen any of those with my own eyes other than this picture, but, and it's not the best repair, but it almost tells, it gives me an idea that there's some method to the madness for laying that thing down. What would be an advantage of laying it down? I think it would be better at sustaining pressure than a normal standpipe, because when that water drops, you know, with each foot you're losing 0.433 psi of pressure. It drops. Where here you don't get nearly the drop because the volume is spread over the length instead of the width of it. So kind of maybe makes sense. They'd even be more convincing if they sanded and painted a little bit every 10 years or something. They didn't do that too frequently. Here's another one that's not the best repair. The design guide says service life expectancy of a storage tank is 50 years. So that's our design guide in Missouri, design guide for community water system. That's their life prediction for a storage tank. What do you think about that? Does that sound believable? Should a storage tank last 50 years?
See, why not, if it's taken care of, right?
Okay.
Should last longer than that.
Should last longer than that. There you
Why
go.
wouldn't it?
I agree with you. Should last twice as long. I mean, if you really maintained it, these folks did. This community left this neglected. That's been long overdue to get some attention. But so that one might not last even 50 years. It certainly won't last what I'm thinking is a double that, 100 years. But a storage tank that's properly maintained on a regular schedule and not neglected could last, like you said, a lot longer, Ralph, than 50 years. Minimum pressure at the, oops, I hit the wrong button here. Trying to hit the little laser light. Minimum pressure that a tank should provide is our 20 psi minimum we should have in a system, but at the base of the tank, near the tank, it should deliver it minimum 35 psi. The working range of pressure in a distribution system typically would be what DNR would want, 35 to 100 psi. Now that doesn't mean the minimum has to be 35. The minimum is 20, but typically between this range. We don't want to go so high, we don't want to go really above 100 psi. We might blow people's plumbing out of their homes, but we don't really, we do want some cushion below before we hit this absolute minimum number. Tank turnover, what would you say a tank should have turnover-wise in a 24-hour period? In other words, when it goes from its eye level, which maybe is here somewhere, and it drops out, what percent of that tank's volume would you expect it to lose in 24 hours prior to being refilled? What do you think? Good recommendation.
Should turn over once in a 24-hour time for the water.
Yeah, I would think so. 24 hours. What they call for is typically at least 25%. So at least 1/4 of the volume of this tank. So if this is the high mark here, then it's going to go down about 1/4 of that volume in 24 hours. So you see, if we do that, and we tend to try to maintain our tanks mostly full, so that kind of fits that, so that we have fire protection, so that we have emergency backup water in case we lose our power and we have a crappy feed down, and we're not without water and not without pressure. But that minimum fluctuation in volume means that there's also not a lot of water the water isn't truly turning over. We're always adding new water with the old water. And again, could very well, if we don't have a mixing system in the tank, could have that thermal stratification occurring like I was talking about earlier. On an elevated storage tank, they really recommend in the winter that you have 50% turnover. So you drop that tank's volume by half of what it can hold in 24 hours through winter months because of tank freeze-up capabilities. The northern portion of Missouri has had in the last 5 years, they've had tank, 1 or 2 systems that had tank freeze up in the winter because of not having adequate movement of water. But you want to keep that water moving, basically, keep it from freezing. So, security, what does DNR recommend for security? That's not a regulatory mandate, but what do they usually like to see for security?
Fence around it.
Okay, good. A fence around the storage tank, so somebody who's in the mind to do mischief doesn't get access to the storage tank, because if somebody's aggravated, mad at the world, might not even be personally aimed at the water system, or it might be a disgruntled employee, it might be a customer who's upset about a water bill or being cut off from water, could target a water storage tank that are out in our communities. If they're not properly protected with a fence, a gate, and a lock. Yes, sir.
I left that, state come in and told us we had to put up a fence around every one of them.
Did they?
They sent a crew guy to make sure they were up.
So
Every time.
they said you have to.
They said we had that.
Is that right? Was that by chance, were you borrowing money from them?
Now that I'm not aware of. I thought it was all due to Homeland Security.
Well, sometimes when you're borrowing money from like the state revolving fund, DNR stipulates that as part of the money we're giving you, we want you to install security around sensitive infrastructure like storage tanks, water treatment plants, well houses, and that. USDA does the same thing. I know one thing after the big ice storm we had down here, all those power lines and everybody out of power forever, it seemed like months, before totally everything was restored. USDA lending money even to really tiny communities, I mean, fewer than 200 people, mandated as part of the loan that they buy backup generators. They actually said, okay, lesson learned, we're going to give you money or lend you money at a low interest rate for your priority, but you're going to include our priority as part of that too. So sometimes lenders do that. Jim, are you aware of any kind of state rule that requires it?
I have not heard anything that's mandatory to fence them.
Yeah, I think.
Other than if it's in a loan, they'll put it in it and make it that way. Especially if it's DNR money.
Yeah.
Well, USDA won't fund it for themselves.
For themselves, they don't?
No.
How so?
Well, we're USDA, Forest Service. And we don't have a fence around ours because they don't want to give us some money to put it in.
Is that right?
Yeah.
Do you have a backup generator?
Yeah, we do. But we did.
My example was.
We didn't
backup
get it
generator. I don't
from,
know.
we didn't get the money from USDA to give it.
Oh, didn't you?
No.
Be more generous with others than you are with your own, right? But in today's world, after 9/11, we got aware that, hey, terrorism really does happen on our own soil. I mean, I think that was a wake-up call for all of us to be aware of. We always thought we were insulated. All those problems were somewhere else. But boy, they're right. They can be right here in the United States. And terrorism doesn't have to happen from an organization led by Osama bin Laden. I know he's now dead, but by a group that have bonded together in some foreign country and hate the United States. It can just be somebody local who's got too much time on his or her hands, or somebody who's got a grievance against the water system, or for whatever reason. And so, it's just good as a bare minimum to have that fence, the gate, the lock around the storage tank, and then to check them occasionally. When I say occasionally, check them regularly, because if the fence is ever breached or the gate is ever broken, you don't want to have to tell the local law enforcement, I don't know, it's been 3 months since I've been there, I don't know how long it's been, because that kind of is a cold trail to try to track down who might have done what and when. But if you can say, well, I know 2 days ago it was intact, that's a little more of a hot trail. gives them a little more to go on and maybe a little more incentive to look into it. Here are some storage tanks that have some security fences around them. Ventilation, vent should ensure free flow of air, corrosion resistance, frost resistance, freedom from fugitive emissions, and sufficient sizing. And this does all of that stuff. This is Tomcat's design, so we've got it up here with their courtesy for their design. This is wonderful. The screen is under this hood, and therefore when the winds blow debris, dirt, pulverized bird droppings, any of those things that could contaminate our water sources, less chance for things to get in. When the rain comes, the freezing rain, the ice, the sleet, in the wintertime, it can't build up on that screen and clog it. It's protected from that, and it's also then protected because of the moisture not hitting it directly, protected from corrosion. So those are important things. I always use an example that's based on humans, but if you were to try to breathe in a deep breath and you were holding your nose and your mouth closed completely and you tried to do that, you couldn't pull any air in. And if you could pull forcefully enough, you would actually cause your lungs to collapse if you could pull that kind of force. And so imagine ice or debris or anything clogging screen, compromising the ability for free flow of air, and all of a sudden you have a major user or a major water leak, and that level drops out and there's no chance to pull air. That's going to be like an aluminum soda can that you just crush in your hand. It's going to cause the walls potentially to collapse in on themselves. Same thing with exhaling. You couldn't exhale if you closed off your nose and mouth, and if the vent can't breathe, it could eventually rupture the tank if you are now rapidly filling the storage tank, it's low. So you really want to make sure to protect that storage tank integrity by making sure the screen is free of obstruction. Also, as another protection against contaminant entry, it seems like in the past what used to be accepted was just a flat lid laid against a big rubber gasket around the rim of the lid, separating the lid from the body of the roof of the storage tank. Those things can go missing. The rubber gasket can go missing, or it can be torn or ripped or defective and let contaminants get in under the lid. Now they say the riser or the stack on the top of the storage tank has to be 4 to 6 inches high and has to have a lip that overlaps it from the lid, so then not on top of the riser you don't have just a flat meeting of metals with a rubber gasket between them, but you have something that overlaps it, again, to protect against fugitive emissions, contaminant sources, from getting in water. Overflow pipe standards. The overflow should be how far above the ground? What's that range?
Twice the diameter? Is that what we're talking about?
No, that is the cross connection protection. This is actually 12 to 24 inches they usually cite, so 1 to 2 feet off the ground. That termination point should be. I've seen some that are way, up there 20 feet high, and you can't inspect them if they're up there, and that's the issue. DNR wants them accessible where you can look to make sure there aren't mud daubers building up in there or something else. I usually talk about a counterweighted flat valve where you got this flap that'll open when the water forces it open, but it's got this heavy old mechanism up here that'll force it to slam shut when the water isn't flowing, and that is a perfectly acceptable method for closure. But this is a different type, this duckbill kind of style here, that the force of water will open it up to let it flow out, but it closes on itself. And that too is an acceptable method. And usually they want a screen insert in addition, so that if there was any chance of compromise or the flap valve not closing all the way, there wouldn't be a bird getting up in there and building a nest, or insects getting up inside there and maybe making their way up into your water column. So those are some additional protections against possible contaminant entry. What's the recommended frequency for inspections? What is it? 5 years, and that's my magic number, 5 years, 5 years. Now, I often hear the folks that do that, those companies, cite 3 to 5 years, and I think, and they say DNR says that, and I think it's 5 years, but they kind of try to shorten that time, 3 to 5 years. And then, just about 3-4 weeks ago, I had somebody from Southwest Missouri call me from a small homeowner association and say, where is it in writing that you have to inspect storage tanks every 5 years? I said, oh my goodness, don't go there. Don't ask me those terrible questions. Like, can they really enforce this? Because I'm not a lawyer, but I can tell you it's not in the regulation. And I didn't think it was in the design guide, but I checked. It's not in the design guide for community water systems. So then I thought, I know I've seen, it was on an internal memo, DNR sending the DNR inspector people going out to be aware of this requirement. But where is the originating authoritative source for that? And so I didn't have an answer to that. And then Danielle West from DNR Central Office texted me a question that she was asking, where is it stated? And she was asking a different question. That's one of those, it's not stated anywhere. It's just something we always say because DNR says it. What was her question about? I have to check my phone and check the text message because I think I still have it in there. And anyway, so I'm going to hit the road. I can't afford to stay around and text back and forth the official answer, which is, I don't know where it's written, but I know you got to say it. You got to prepare people for the exam, and that's one of those questions you got to tell them about. So I thought, I'll just call her. So I called her, and then she was in the company of Darlene Helmig, operator certification, and they were asking about this question, and I said, I don't know where it is, and in the meanwhile, when you're looking and asking some of your folks where that is, ask them about the water storage tank inspection thing. Where in the world is that written anywhere? I think it's in a memo. I think I had it. I looked after I got that call a few weeks ago. I couldn't find that anywhere in my resources. So they ended up sending me resources for both of those questions. I bothered now by not remembering off the top of my head what that other question was. But and there was a PowerPoint slide. I still don't know where the original source of the is, but it does say storage tanks should not go any longer than 5 years in between inspection and clean out. So anyway, that's the extent of it. It's not a regulation. It's not a regulation. It's like you should exercise your valves every year. You should flush your lines every year. It's not a regulation. Now that's just good maintenance. Just like it's not a regulation, you got to change oil after 3,000 miles in your engine. It's just good maintenance. It's not a regulation. But DNR still kind of holds you to it because when they come for their inspection of sanitary surveys, they actually want to see the records for when your last tank inspection was, right? And they might cite you if you don't have an inspection within the last 5-year time. So they treat it like it's regulatory. Considerations for normal inspections, corrosion, screen. That tank needs a little tender loving care, doesn't it? Functional components. level sensors, pressure gauges, altitude valve, code compliance for things like hatches, vents, ladders, structural integrity of the unit, all kinds of things they look at. So it's really important to have an expert do the inspection and check it out, you know, that's it. And that brings us to a related video.
On the news this morning, I saw where people had blood worms coming out of the taps. This community is evidently infested, and I'm gonna go down there and see for myself what's going on. We did a little studying on the subject, and the bloodworm is a larva from a fly. Somehow, flies are evidently getting in the water storage tank. My first thought was it just hasn't been cleaned, and you have contaminants growing in the sediment. So we're going to go down there and talk to some residents and hopefully talk to the water supplier and see what's happening.
About 3 days ago, I put water in the bathtub and I noticed worms in there. And then I started seeing on Facebook that other people were having the same problem. We said, let's contact news and get somebody out here to see if we can get something done with this. I've never drank water here, never have since the 14, 15 years I've been here. I've always drank bottled water, thank goodness. But, you know, we to bathe in it, brush our teeth, and people that do drink the water, it's sickening.
I mean, bottled water, we never drink the water that's here. When people started really noticing it, when the water got turned off, it got turned back on, people were really looking at the water hard, and that's when people seen the works in it. I mean, and how long we been in there? Who knows? You know, nobody's ever paid a close attention to the water, you know? If it's dirty water, like, a lot of times this water gets shut off for 3 or 4 hours. When you turn it back on, it looks like mud when it comes out. Yeah. You know, but this time here, they had about 16 hours. When they turned it back on, everybody started noticing little bugs in the water, and that's when it become an issue for everybody.
We haven't had the worms since the problem first started until today. It was the first time my mother was cooking some ramen noodles for the baby, and there were blood worms in the bowl. So I notified TCDQ that this was the first day that we had noticed the worms, and that I understood we were under the boil notice. We can boil the water, that's fine, it makes sense. However, it seems to be that there should be bacteria in them blood worms, so we still have to bathe in them. Will that bacteria hurt us from bathing is my biggest question. We can boil the water for cooking, we can use supplemental water for cooking, but how do you go to somewhere to bathe, whether it's at a community building or a motel? It's just, we're worried about the bacteria bathing, basically.
The best I can figure out from this is a few midge flies are about the size of mosquitoes. And if they have a breach in the tank somewhere, flies can get in. We saw one case where the dumpsters were really close to tanks. If I had the ability to inspect those things, I would be looking for a breach, a corroded spot, a hole, a vent screen that was corroded or blown away, see anywhere flies get in. The other thing I do is I check sediment levels with an underwater camera to see if I'm right and the worms, the larvae from the midge fly is using that sediment, you know, to reproduce. If it's going the way that I think it is, and I give my assessment off to some people I know at the EPA, they agree with my assessment, the larva was in the sediment, and over the weekend they lost power to the plant. When that happened, the larva expanded beyond the safety of the sediment. The colony moves up towards the tank. As long as the tank has circulation, they can get the oxygen they needed. When that didn't happen, they had to go to the surface to get the oxygen when they lost the circulation. So they had 2 days to expand out into the tank. Then when the pumps came back on, the little worms were pumped into the people's taps, bathtubs, toilets. Our deal is we need a regulation that puts a timetable on getting tanks cleaned. Texas has a rule under Texas Administrative Code 290.46 that says tanks have to be inspected once a year, and tanks get inspected once a year as a result of that rule. We also need some guidance on cleaners supposed to clean. It just can't be as needed, because everyone doesn't do the same kind of inspection. Some people look inside water tanks, and some people don't. My company uses underwater cameras to see what's going on inside a water storage tank, and when we see sediment levels building up, we go back in and clean it with a diver. However you clean it, whether you take it out of service and clean it with your own people, or hire a contractor to come in and clean it, they just have to be cleaned periodically. The American Water Works Association says you should clean a tank every 3 to 5 years or as needed. It doesn't matter how long ago they cleaned their tanks, they need to clean them again. Inspecting water storage tanks and towers is incredibly important. It's also dangerous. The Environmental Training Institute recognizes this, and they've developed a course to help you understand what you're looking for, what you're looking at, and how to do it safely. It's a 2-day course. You can find more information at the Environmental Training Institute at University of Texas at
The last part is
we have
just
the online
a sale of a class there. I thought he had some words of wisdom at the end. I forgot that was just a sale. I did check my text message though just while that was on and saw that was her question. Danielle West at DNR in Jeff City was asking where the 10% come from. So I knew right away she meant the water loss. Water loss today is considered 10%. Anything above that is considered not acceptable by DNR. Below that, so 10%. So you know, I was going to say, what am I going to do? I need to hit the road. Am I going to sit here and say, well, it's not in the regulations if that's what you mean? Better just call her and say, I don't know where it came from. Maybe the 10 state standards, maybe it's an American Water Works Association thing. I think it's an Everett Baker thing from Macon, Northeast Missouri, and I think he just said it in a memo, because I didn't think I saw it in a memo somewhere. So I said, see if we can find somebody there who's been around long enough to know. And while you're doing it, tell me where it's written. You gotta inspect your storage tanks every 5 years. So I did that. Opened up into those things we teach for the sake of the exam that really aren't written anywhere. They're just kind of a fuzzy policy of DNR. All right, so I was relieved that when I saw that video at first, I would have sworn on a stack of Bibles that this is Missouri, Southeast Missouri. This was Texas, right? Yeah, you've been there and done this one, same thing, right? The midge fly larva. Did you want to tell us about your experience there, Jim? Or what do you think caused it? That guy had his theory that when the pumps were no longer pumping for a couple of days or whatever, they were coming up to the surface for air or whatever. But
well, this was a well system, unchlorinated, and their water pumps pretty warm. It's not the 52 degrees like most wells, deep wells are. They're pretty shallow and they pump warm water. The only thing we could find when nobody, it's been several days before anybody even knew it, and some customers called the system, and then the system called us to help them figure it out. And the only thing we could find was their overflow on one of their towers was busted. We think some ice, not long after winter, we think some ice had busted, fell down and busted the screen out of the bottom of it, and the midge flies got in it, and their whole system was contaminated with the worms. I mean, you could run a glass of water and see the little worms floating around in it. And needless to say, the first thing we did was put chlorination on for them so they could chlorinate it, and then we flushed for a week before we got it all out. Or we think we got it all out.
And if I were the water operator of that system, one thing I would want to do is continue chlorinating from that point forward.
They have since disconnected the chlorination because there's no mandatory chlorination. So they've since, I think they've disconnected.
Yeah, that's what I believe is the case.
But there again, it shows a good reason where we had our towers climbed every year when I ran the system, because we had a vent somehow come off of one. Drive up one day and there lays your vent off the top of your tower down there in the driveway, things like that. So, I'm a firm believer that you ought to have it climbed every year, just to check the vent and the hatch. And of course, anytime you overflow your tower, you want to look at the overflow to see if you got any bird feathers or anything in the overflow screen, But now, as far as washout cleanout, like you said, there's no regs on that, but you need to know if it's got sediment building up and if your paint's chipping on the inside. And 5 years is a pretty decent time frame. I don't know where they come up with that, but I think you ought to do a visual inspection every year anyway.
That would be a good idea. And this gentleman talked about in Texas, maybe as a result, I don't know that, but this incident, they require it every year. And I think he was talking about a visual inspection, or at least he was doing a visual with his flashlight up there on the top.
I think if the majority of the DNR violations, if you track them down, that bad samples that are E. coli or such are typically from tower problems. So, that's a good sign that you ought to keep track of your tower pretty regularly.
I'd say it's a great endorsement to basically just kind of be more proactive when we manage our water system, our storage tanks, and that, again, in the heat of summer, even in a disinfected system, there could be, unless you got circulators in those systems, there could be stagnating water at the top, settling to the top, that warmer water, and that is an invitation for growth of coliform, which could cause you to have at least issues with coliform. Maybe not bloodworms. You don't have to have bloodworms in your water system. That woman could be the customer of almost every water system I've ever been to, including my own water system that I manage. I've been here 15 years and I've never drunk that water, thank God. I mean, how many people I've heard say that about their water? They don't have to have, and I don't, after that, I wouldn't blame them. I wouldn't ever trust my water again, I don't think, from that water system after bloodworms were in it. But you don't have to have it for people that do not trust the water. That's kind of sad. But anyway. Storage tanks that hold 30,000 gallons or more are required to have a hydrant for draining the tank. So that's just one of those, I'm going to say, obscure piece of information. Obscure if you don't have those types of tanks. Yeah, then you probably aren't aware of it. But if you were building one, then hopefully the engineer designing it is going to be familiar with the design guide for community water systems and is going to make sure everything that's required is in place. So just some hydrants or flush outs near storage tank units. Water systems that use hydromatics tanks or bladder tanks as a sole source of water are systems that have 50 or fewer connections. Those are the sizes for a system, if that is their sole source. Air to water, what's that air to water ratio? Should be 1/3 air to 2/3 water in a hydromatic tank. And then you also see a lot of times in small systems, the little bladder tanks that hold water and air, separate the two to sustain the pressure. And there's just some other details from requirements for systems that use this. Must have at least 2 minutes of discharge from your largest supplying pump. So consequently, some well houses will have 6, 8, 12 of these little bladder tanks in them. No, we're not going to do this. Designing it, I was planning us to use a map, and as Howard Baker showed me with Diamond Maps, and actually, Howard does our mapping. So he's a mapping expert. He's got the mapping software, sophisticated stuff on his computer And then on our mobile phones, what we can do is go to, for a subscription, you can go to Diamond Maps. In Diamond Maps, you can actually manipulate, as in open up your maps, overlay details, you can add features, you can change features on your cell phone right when you're out there in the field. It's kind of cool. And so he's got it so that I can have, well, I have access to it on the internet, but the internet here is a little sketchy. And because it's this late in the day, I don't know if I want to try to connect to the internet right now. So I think I'm going to let that detail go. It is a little bit going the reverse of a map. You have these features installed. You've got lines, you've got valves, you've got hydrants, you've got blow-offs, you've got pressure reducing valves, you've got sample site for collecting your bacterial samples. You got all those in place, and then you put them on a map. So what I was going to do is go the wrong way. I was going to go backwards. I was going to have a map with some features on it, and we would then take the map and we would add features to it, which is partly what you would do if you had an existing map and you're extending lines or you're adding valves where you didn't have valves and stuff like that. But I think I'm going to forego that today. I haven't really tried it yet in a class, just because it seems like I have so much material that I probably have to trim back what I've got. I'm already trimming back those very things that wouldn't open earlier. I got rid of them already, those slides, so maybe in the future. So we'll talk a little bit about distribution mains, pressure ratings. These are the manufactured pressure ratings for what the pipes are meant to withstand, not what you would normally see as operating pressures in a distribution system. So sometimes that gets a little confusing for folks, which is which, and simply what they're meant to withstand. Let's match. What type of rate is a rupture? We'll give a little bit of detail there. Which one shows a rupture? C, okay. C, yeah, it's the pressure internally exceeds the pipe's ability to withstand the pressure. What about a crush? External pressure. Okay, good. D, external pressure caves in, crushes in on the pipe. Shear. Shear, actually, it would be a B. Would be B here. A split along the length of the pipe is usually what that is, shear, and then this would represent a break. The line just breaks in half, severs in half or something, typically because of some rigid thing that's on, maybe, and some movement of the ground in freezing, cracking, drying, hopefully dry ground in the sun. More about rupture. So every velocity change will cause a surge in a pipe. 1 foot per second velocity change will cause a 50 psi surge. Typical velocities in a water main are 2 to 4 feet per second. So at the upper end of that range, 4 feet per second, 4 feet per second times 50 would be 200 psi surge. So that pipe also needs a little care. Time for a repair plant, or 10 on that pipe. Just images of repair plant. Durability, how long should pipe last? Talk about storage tanks.
Forever.
Forever, right? Good. And my answer is going to be very conservative and say 100 years, but I agree, forever, really. They should last. As long as we're maintaining them well, as long as we don't have external circumstances like aggressive soil, if we've got metal pipe that could be slowly corroding our pipe, or aggressive water that is corroding the inside of the pipe wall if it's metal. But, yeah, if they're maintained right, they should last forever. That again assumes we don't have a lot of mineral hardness causing a lot of scale buildup. You know, if we really flush well, maybe we can keep that from also closing in on the pipe.
Well, that chance you always get from the bean counters.
Forever? Is that right?
Oh, yeah, everything's supposed to last forever.
Oh, everything, the operator included, right?
You don't have to replace anything. It's all good. It's working, it's good.
They're taking into account that some human had to install that at some point, and you're assuming that they did what they were supposed to do.
There
Which contractors didn't do.
Contractors do tend to take shortcuts, don't they? Shortcuts do mean you're out in the middle of the night or on a holiday working a break because somebody didn't do the job right. Or that line now has to be replaced because it wasn't installed properly and we've got so many breaks in it, we're tired of wasting repair plans. Yeah, excellent. So there are some assumptions built into the forever. I always think that when we make a major purchase, whether it's an automobile, a washing machine, whatever it is, or a water line, a water system, a brand new water treatment plant, maybe, whatever it is, it should be problem-free. It should not need repairs because it's new. But I do like to distinguish that from a different thing. It should be maintenance-free. No, everything, even brand new installations need maintenance. So I've talked to operators who have had brand new water main, all of their old mains replaced. I said, now you got more work to do. Because now you want to make sure that when you pass the torch to the next generation, whether that's 2 years from now or 20 years from now, that you give that next operator pristine pipe that you haven't let it deteriorate during your shift, right? So, you know, I kind of look at it as when I've got something new, it requires more care in a sense. So it kind of depends on how you approach it, I guess. Inner surface corrosion resistance, satisfactory flow characteristics. Forever, I like that answer. I have heard from manufacturers 100 years, and I think that's really believable. It is believable, even though there's a lot of pipe out there that's way less than 100 years busting up. But I think if it's properly cared, 100 years, because forever might be possible. What's this thing? C factor.
Smoothness of the pipe.
Say that again, Michael.
Smoothness of the pipe.
Smoothness of the pipe. Yeah, how rough or smooth is it? That depends on this my glass half full or half empty. But typically, how smooth or rough is that pipe? So usually that range is, I think, 80. What I've seen, 80 to 150. With the upper number, 100 to 150 being real smooth pipe. Imagine PVC pipe, brand new off the rack, doesn't have any scale built up, no tuberculation or anything in it. Nice and smooth. That's the upper end of the C factor. The lower end is when you got a lot of buildup. Installation features, weight, size, joining, tapping. You look at those things. How easy is it to join to other pipe? How easy is it to tap or install? Weight of the pipe, the material type, all plays into it. Just some other images here real quick before we stop. Standards in pipe. There are different institutions that give standards rating for pipe, and you'll see it stamped on pipe, the outside of pipe. So we've got the American Water Works Association we're talking about. Then there's also the American National Standards Institute, ANSI or ANSI. And then the American Society for Testing Material, ASTM. They're the ones that rate what pipe is supposed to withstand, how much pressure, and that kind of stuff. Types of pipe, we've got cast iron, asbestos cement, I'm gonna stop right there. Asbestos cement, I just got some. From that same place I got that piece from the positive displacement pipe. I got this in here so you don't have any fear about breathing in the little filter fragments from this pipe, because it is supposed to be a threat for cancer, breathing it in. So it's not anything you're going to have to worry about respiratory-wise, but I'll pass this around. If you pass it, make sure you don't just slam it on somebody's finger, but you might just take a look at that and pass it around. So just a piece of asbestos cement pipe that was recently removed from service. Hadn't been in service. It was in service probably 6 months ago, I imagine. We've got plastic pipe, we've got steel, concrete, service pipe. Service comes under all kinds of categories. So the old gray cast iron pipe that isn't really being made anymore is really good. It's tough, impervious, it's internally lined. It has a variety of sizes, 2 to 54 inches, a long lifespan, and it's pretty versatile for use. And then you've got ductile iron. It's stronger and less rigid than gray cast iron, so that's good. It's same internal lining, sizes, life, and versatility. And it's got some corrosion protection because it's got a lining in it. So this is what's in use and what's pretty common, especially in high pressure areas and distribution systems. What is this made out of? This is made out of old scrap metal. They go to junkyards where they got old cars, and they take cranes and pick them up and they crush them, they bust them apart, and they separate the materials, and they use the different metals that they find, the steel and alloys in it, to make this type of pipe. So kind of an interesting process. Joints of cast iron, bell and spigot, flange, ball and socket, mechanical, and then more recently push on, got flanges there. We do get a little bit, this is a quantum coupler, universal coupler for pipe that has different outer diameters. So like a C900 pipe versus a PVC pipe, even if they're both 6-inch, they have just a little difference in their measure. So a universal coupler can bring them both together. And you'll see a little deflection, as in it's not straight, it's bending there just a little bit. So a little bit of deflection allowed. So we've got iron ductile there, flange joints, mechanical joints and molds, and transition gaskets and molds for iron pipe. There's another picture of the universal coupler. And I'm thinking Quantum maybe is that the manufacturer name, Quantum? Is that a product name? I'm not sure. I think Universal is the type. Another image of it. There's good old asbestos cement pipe image. So those fibers are a threat to our health. When you're grinding or cutting through that pipe, you should really wear respiratory equipment. It's pretty lightweight and durable. It resists corrosion. It's got a nice polished interior. I've had operators say, boy, it's lasted a long time, including the operator gave me that little piece. Said it's been in place for many a year. What it doesn't do well is it doesn't bend. So it doesn't have what they call flexural ability. You bend it, you basically break it. It's rigid that way. Plastic pipe, we have different kinds of pipe. PVC, polyvinyl chloride, polybutylene, high density polyethylene, and acrylonitrile butadiene and styrene, which isn't very common anymore. Joints, bell and spigot, solvent well, typically use, like glue. 1/2 inch to 36 inch for the AWWA standard C900. Otherwise, we're talking 4 to 16 inches, common sizes for PVC. It will become brittle under sunlight. rigid. There's a bell and a pipe, and the image of the gasket in there, but pretty dirty looking pipe. But it's the bell in there, and then the spigot has got this chamfered end. It's a fancy way to say it's beveled inward to allow smooth sliding over of it with the bell fit in that gasket. And there, sunlight deterioration scars them and makes them much more susceptible to breaking or becoming rigid sunlight. High density polyethylene, HDP, I don't know, this might be what you use in a well, if you were dropping it at home in a private well maybe, but I don't know that you'd be using this actually in a line. You'd be using a rigid pipe, but the black pipe is often used for gas lines. It is supposed to be very durable. It allows for deflection, for bending, and you basically weld it together or fuse it, the ends together, kind of like you would do with copper pipe. It's expensive, but it really is very durable, has a thick wall. And I don't have in this image, and something that's kind of in the in-between between PVC and the polyethylene is the ultra blue. Is that what it's called? Ultra blue, I think is what it's called, ultra blue. And they, we actually went to where they manufacture ultra blue in Columbia, and they gave us a tour, and it's kind of PVC. They extrude these ends out to make the bells after they heat this stuff. It's a really thick, I almost want to say 3-inch thick wall that they stretch to make larger size pipe. And of course, the wall, the pipe thins out as they extrude it. It was a pretty interesting tour through that facility to see that. And they show demonstrations where you can drop that. You can have water, get capped in water, and pressurized line, and they pick it up with a backhoe or a trackhoe, and they drop it and roll over and all kinds of stuff. It doesn't pressure, it doesn't break it. So they try to show it's basically unbreakable. Of course, everything's breakable, but it can take a good beating and still perform pretty well. Polybutylene, join like polyethylene pipe. ABS pipe is kind of weak. It's not in use as much anymore. Characteristics of plastic pipe is that it has a nice smooth interior, so a high C factor in there. It's lightweight, it's not subject to corrosion. It doesn't matter if it's in corrosive soil, and it doesn't matter if you have corrosive water going through it. It's flexible and very versatile for use. PVC, typical pipe in use. I think PVC, I read a statistic that said 80% of all pipe installed today is PVC for water systems now. It's kind of the go-to pipe because it's light and it's pretty good at withstanding pressure fluctuations and stuff. Steel pipe, fabricated cutting, bending and welding. They've got all kinds of methods for manufacturing this pipe. So it comes in rolled sheets available in 4 to 144 inches. Mill, scrap steel plates are put into a furnace, heated really high with pig iron, and they kind of purify the metal and all that. It's a pretty intense, interesting way to make the pipe. It's really a good pipe to have. Withstands external pressures as well, except when the pipe gets big. I mean, when you get a bigger pipe, it's more subject to external weight of pressure against it. Mill type, they use scrap steel, can be electrically welded. Comes in sizes 1/2 inch to 80 inches, and they've got that perfected so well now. I read that they can actually take 1 million pounds of steel, produce 1 million pounds of steel steel in 40 minutes time with this mill steel. So, seamless, very limited sizes. Lightweight, strong, easy to work with. Corrosion resistant as long as it's internally lined, which it usually would be. Usually cement mortar on the inside. Steel pipe, metal pipe in general, where you're gonna meet up with corrosion or moisture, damp areas, you probably would use coal tar around the pipe, or you would use polyethylene. I've seen that in one location. It was in the city of Macon at their water treatment plant, where it was a real damp environment in the pipe galley under the filters, and they had the polyethylene wrap on their pipe to keep it from getting corroded. And it looked like, go to the hardware store to get that triple expanding foam if you've ever used that. It looked like that stuff, about 3 inch around the entire pipe, to protect it from that moist environment. Large pipe requires a vacuum relief. Common joining would be welding, compression couplings, brake couplings, flange joints. Steel cylinders are pre-stressed, which is simply to say they're reinforced for durability, or not pre-stressed. And then you also have non-cylinder type pipe that's not pre-stressed. Concrete pipes used for transmission lines typically, and also distribution lines. Sizes that are greater than 12 inch tend to be cheaper as material costs for pipe than a smaller pipe. Strong, they need a modified development spigot, but they're kind of hard to work with in some ways. They're heavy, they're hard to tap, and they need special equipment. This is just an image, or not an image, an actual video about the manufacturing of, and I thought it was one of those how it's made videos, and that's pretty cool. I'd throw it in.
Most underground sewer and drainage pipes are made of reinforced dry mix concrete. Reinforced refers to the fact the concrete has steel bars inside it for added structural strength. Dry mix refers to the type of concrete. You can mold it and immediately extract it, and it holds its shape. Concrete pipes can be as small as 25 centimeters or as large as 3.5 meters. It has a 100-year lifespan. Dry mix concrete is made of stone, coarse sand, Portland cement, which is a finely ground blend of clay and limestone, water, and a chemical that acts as a water reducer. Trucks unload the sand and stone into outdoor storage bins. The materials automatically drop onto a conveyor belt, which transports them to storage silos above the factory floor. The cement arrives by cement tanker, which blows it into a silo. All the silos feed the mixer. As the ingredients blend, the cement and water combine to form a paste that coats the sand and stone. The water reducer enables them to use minimal water. The less water, the stronger and more durable the concrete. Meanwhile, workers use a special machine to build what's called the cage, a circular steel frame that will form the pipe's internal structure, its backbone. They insert 2.5 meter long steel rods in a circular configuration, pushing each rod partway through the machine to the other side. There, an automated spot welder fuses a steel cable to one rod. Then the machine begins turning, winding the cable tightly around the rods. Here, a worker is turning the machine manually just to show us the process in slow motion. This is what it looks like at the normal automated speed. As the rods pass through the machine, the welder fuses the cable to them in one continuous spiral. As the spiraled cable reaches the end of the rods, the machine's claws spread outward, forming a wider section on the end. This is called the bell section. Workers position it on a base frame designed to hold the cage in place. Then they close a hinged steel mold over it. Now they're ready to pour the concrete. A forklift transports the mold to a machine called the packer head. They position the mold directly under it. A long drill-like screw descends into the mold. As concrete pours in, the screw turns at high speed, moving up and down. Its blades propel the concrete outward against the mold walls, forming the pipe. This process is called centrifugal projection forming. The process for making large diameter pipes is slightly different. A welder fuses spacers to the cage, both inside and out. These will center the cage inside the mold. Workers position the cage onto a base ring, then lower the outer part of the mold, called the outside form, over it. After securing it to the ring, they lower the unit over the smaller inner part of the mold, called the inside form. An overhead funnel pours concrete into the cavity between the two mold forms. Powerful electrical vibrators shake the mold. This forces the thick concrete downward, filling the cavity. This process is called vibration forming. With either pipe forming technique, the molded concrete is quite fragile, so the molds go off to the curing warehouse to harden. There, workers remove them, leaving the pipe standing upright. Steam hoses transform the curing warehouse into a sauna. The temperature rises to 60 degrees Celsius, the relative humidity 100%. The concrete hardens in about 12 hours. Concrete pipes buried underground have to be able to withstand the weight of the earth above them, so the company subjects sample pipes to extreme pressure to test their maximum resistance. Concrete pipes join together with watertight rubber gaskets.
All right, so just a thought. And service pipe then comes in 3/4 inch to 1.5 inch. It's made of all kinds of different possible materials, and you see a good list here: copper PVC, polyethylene, polybutylene, brass, cast iron, wrought iron, steel, asbestos cement. Owner's responsibility is between the meter and the residence, so on the other side of the meter, or sometimes from the main to the residence. And I am working with a system up in Northwest Missouri where the homeowner owns the entire service line from the water main all the way into the home. So there are some rare instances of that, but typically it's on the other side of the meter. Some dress couplings of different sorts here, some images here. Corrosion properties. So we talk about which pipe will withstand corrosion better. Copper typically will resist corrosion, however, some soils can defeat it. Potential contaminants would be copper. And then there are some exceptions down here. This note talks about if we have high velocity, soft water tends to be corrosive. So soft water, chlorine, or especially fluorine, fluoridated water, can wear on metal. Lead corrodes in soft water, low pH. In warm water, and fluorines tend to be more aggressive when it comes to lead than chlorine. And the threats there are lead, arsenic, and cadmium. Mill steel subject to uniform corrosion. And we see iron turbidity, breakthrough, red color issues with customer. Cast or duct iron, surface erosion in aggressive water can defeat it and release again some red color, ironized water. galvanized corrosion, zinc and iron. Asbestos cement's pretty good. Aggressive water can leach out calcium though, and the asbestos fibers are what we're concerned about there with that. It's not really available anymore, and it's just what we have remnants of in our system of that. Plastic is, when it comes to the choice of corrosion material, plastic is the go-to material because it doesn't have issues with corrosion. So pipe handling, basically inspect the pipe, make sure we handle the pipe carefully, especially if it's internally lined. We don't want to rust the lining by banging it against anything. We store, cap both ends, try to prevent contaminants from getting in. Typically with bells, you would store, if the pipe has bells, you're going to store cells on alternating ends with each layer so that you kind of keep the stack blade level. For installing new pipe, of course, we want a construction permit to do that, and we want to dig, call dig right. Bear did not, and we did. So we look at all these different types of utilities. What are these markings? Can we match colors with what they represent? What would be a white? What does a white marking represent?
Temporary.
Temporary. Where's temporary? Temporary down there. It would be right there. Proposed excavation. And pink. What's it going to be? Pink is going to be temporary. So I'll get rid of that one. How about red? Okay, electric, down the bottom. Power lines, cable, conduit, lighting. And then yellow?
Gas.
Okay. Gas, right up there at the top, is oil, steam, petroleum. Orange? Okay, communication. Alarm, signal lines, cables, conduit. Blue. Okay, good. Where is that? Oh, there it is. Potable water there. Blue. Purple. Okay, good. Reclaimed water, irrigation, slurry, spray water, whatever. And then green, our last one there. Towards the drain line. Good. So trenches, we want to be pretty narrow, not excessively wide, because if we build a trench too big, too wide, too long, it becomes a potential hazard. Proper depth, free of debris. I like the shoring. He's got that installed in there. So for safety, if we take a minute to talk about safety, everybody practice proper safety on using shoring when you're in a trench. Do we have them and use them?
When you're shoring,
Say it again. Who was it?
so when you're shoring, on the shell back, we don't have the ends for it. There's not. If we get anything that deep,
Okay. So how deep does it have to be for us to protect?
anything over 4 foot, they're probably start notching.
It's probably a good idea.
And 4 foot, you want to do a 2 foot notch, and
Okay, so you kind of,
I've actually had them sliding too, so.
okay, yeah, so you kind of step.
Yeah.
Okay. Anybody use a trench box, pre-made, or an easily assembled on site kind of a device?
Both the trench box and the hydraulic shoring jack there with the 2x12 and with the plywood.
Okay. Yeah, something there against the wall on both sides of the trench. Good. Move obstruction. question, dirt pipe, swamp pipe, or pipe carefully. Yeah, this one's a little longer, but I'm gonna get rid of the first part of it, because the first part of it is a backhoe breaking asphalt and removing asphalt to get to this line. I think we can get rid of about 50% of this and get rid of that portion, because that's kind of leading up to the actual deal. Let me sit through, assuming my computer lets me do it. Okay, they're getting down to the line here. that video, but threw it in there.
It did show why you need shorter than a deep ditch.
It did, didn't it? It started to collapse on the other side of that trench box. So that was at least good to witness. So potable and non-potable lines to avoid cross connections. Acceptable distances when we're installing water lines, sewer lines would be, when they're running parallel with each other, what is the separation? Minimum separation, remember? 10 foot. 10 foot. And then if they have to cross, if they've got vertical separation, ideally the water line be on top. That separation be about what? 18. That was 18 inches. 18 inches. So that vertical separation. Sewer line reinforcement encased in ductile iron pipe and pressure pipe joints for 10 feet on each side of the crossing where they cross. And then for pipe that's laid under railroad tracks or roadways maybe, there's heavy vibration and weight always on the pipe, then it's a good idea to have pipe inside of another pipe that's 6 inches larger in diameter than the water pipe itself. And it's got its nice protective cushion around it, separating it from the larger conduit. Bell facings typically are in the direction if you're laying the pipe, but on hilly terrain, then typically what you would do is face bells upward to try to put less stress on gaskets. Other joints not important. We use feeder gauge to make sure we perfectly align gaskets. Thrust blocks, good restraints. Again, when water changes direction or velocity in the pipe, it can shimmy the pipe, cause damage, cause joints to break apart. So we either use concrete brush blocks or mechanical joint restraints. Those have become more common now. I think who uses mechanical joint restraints and MJ restraints? That is little grippers, those little, when there's any pressure or tension, I should say, as it pulls it, those grippers come down, grab at the pipe, and won't let it separate. Bedding bells, backfilling. We want to backfill and cover the pipe in length. Basically, when we're putting in a new pipe, you've got to remember tracer wire if we're talking about plastic pipe for locating later. But we usually leave the joints exposed because we want to do a pressure test and increase that pressure 1.5 times our usual operating pressure and see how we can withstand that pressure at the joints. We want to be visibly able to see leakage if we have it. Use hydrostatic pump and drum potable water to inject and increase your pressure. And then be careful when you're destabilizing or depressurizing the line. And if everything looks good, backfill it. Disinfecting the new main, leave super disinfectant for a sufficient time. Work all valves and hydrants. And use diffuser, typically a chlorine neutralizing agent. Typically sodium thiosulfate. That name sticks with me because it's the stuff we use in the little bacteriological bottle. What the DNR often says for superchlorinations, 50 parts per million after 24 hours of hold time. What AWWA says after 24 hours of hold time, you use 25 parts per million. And you should have at least 10 parts per million residual left in the line, or otherwise, I guess it's just heavy contamination to do again. Work valves and hydrants, make sure every surface exposed to the water gets disinfected, gets thoroughly cleaned, And then when you're dispensing with it, it's used to keep from eroding the ground and those chlorine neutralizing agents, so we don't have high levels of chlorine spilling to the ground. We fill our line, typically we fill the line with what our normal water is, whether it's a chlorinated system or not, whatever our water normally would have in it. The alternative methods for speeding up the process, 100 parts per million chlorine you can use and have just a 3-hour hold time instead of 24 hours. And then you should have at least half that much left over, 50 parts per million at that point. For working an existing main that you want to really speed up the process, you can use 300 parts per million and test it after 15 minutes. And as long as you have at least 100 parts per million residual left, you are good to go. Then you can drain it and refill it and start taking your bacteriological samples, your special samples. So, discharge water, take special samples. If you have bad results, you might have to repeat all that. Release water for public consumption. I think Jim might have mentioned this, and I've been a conversation on a break, I don't know, talking about removing buildup in lines. So we have these 3 devices. The swab here is in the center, just like a big sponge, really, put in for loose sediment and a non-heavily encrusted scale. Pigs have this vinyl jacket around them that gives them a little more ability to withstand resistance, so that they can be used for a little heavier encrusting scale tuberculation. And then any number of designs of these scrapers that have the bristles on them, and they're meant for the really toughly encrusted tuberculation inside a line. So sometimes you might do them in stages. You typically use a wide fitting to insert them, and then a wide fitting on the other end to take them out. When you run a pig or a swab or a scraper through, you're going to get really terribly, horribly looking water. Typically you're scouring out that line of all the junk built up and all the stuff underneath that. So it might come out looking like crude oil, really. Count the devices again, then you're going to do a disinfection, and you're going to flush in that before you put it back in use. And then it gets down to our minimum. We're kind of getting down to the wire here, folks. Our minimum disinfectant, DNR says 0.5 milligrams per liter. Free chlorine is the minimum at the entrance to your distribution system. And if you're using chloramines, it's 1.0 chloramine residual or combined residual going into your system as a minimum. And then at the far ends, or really anywhere in your system, should be no less than 0.2. Now down here in Southwest Missouri, Springfield Southwest Regional Office, as well as Poplar Bluff Southeast Regional Office, say 0.5. They'll preach it to you like it's regulation. I used to teach it when I started with reservoir water and found out I was not right because they preached it so much. I thought that was regulation. It is not regulation. This is regulation. However, I understand now the Southwest Southeast regions want that to be at 0.5. That's not much of a cushion above that 0.2. And so it's certainly something we should strive to achieve, help satisfy their wishes. Maximum residual disinfectant levels. So the maximum allowed for chlorine and chloramine is 4.0 on a running annual average. Chlorine dioxide is 0.8 milligrams per liter. And that really is all I have. Hey, gee whiz, we have another 40 minutes. I could have done that. Now, I think I'm going to tidy that up a little bit. It's a new class, really, that I've only done a few times, and I think I'll tidy it up a bit. Maybe in the future I'll be able to do that mapping thing. But I appreciate your participation today, and give us a holler, Missouri Water Association, if you ever need anything. Anything, Jim, last parting words that you have?
Goodbye.
Goodbye.